Hot chocolate, Azure, Cosmos, Entity Framework, our tool, Technology Suite,
Countdown commencing. T-minus 2 minutes.
Jeremy Likeness,
ShayRojansky,
Chris Lampson,
Martha Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Awesome. Welcome, everybody. It's another month. That means another stream about the .NET data, EF, and everything data related. We are live. Today, we have a great guest, but before we introduce the topic, or actually you can read the topic from the name, right? From the title of the stream. We need to do the same dance we do every time and talk about current preview. So we as a team are currently closing in on the release candidates that will be released a little bit later. If you want to play with EF and everything data related, you can try preview 7. That's out now for quite a few days. And to talk about EF Core 10 Preview 7, what's new in there and what you can expect, there is one big feature that was finished for Preview 7, and it's another option for translating collections that are parameterized collections. Now we also allow you to translate into multiple parameters. So you can choose between constants. You can choose between one parameter that's actually a collection and uses usually a JSON function to extract it, and now also multiple parameters. There's a great documentation in the release notes, and we will be improving the documentation as we go closer to the final version. Each of these translations has its own pros and cons. So there's definitely stuff to deal with if you are hunting performance or if you're having performance issues. Other than that, some small improvements around SQLite and translations. Again, you can check the release notes that are available. With that, Shay, do you have something about Preview 7? You are muted.
As always, yeah. Hi, everybody. No, I don't have anything to say about Preview 7, but I do have something to say about RC1. Just for everybody's information, we actually just what we call branched for RC1, which means we've locked it down, and RC1 is coming out in less than a month. RC1 contains a ton of stuff. This frequently happens. We worked we worked on many infrastructural things, but you can't actually see them during the the development. And RC1 is sometimes when it comes together. So look forward to RC1, where we have a ton of new features in EF10, which you can play with. RC1 will also be what's called a go live license. So you're officially like supposed to be okay to use it in production and things like this, even though it's still in RC1 and has bugs. So as always, be careful. Be careful even when it's GA, when it's not in RC. But I'm personally very excited. And we're already doing stabilization for RC2 on bugs that we already know are there. So yeah, it's all quite exciting running up to the actual final release of EF10. That's all I had to say.
Awesome. Yeah, for me, it's always a little bit weird that I'm talking about a preview, but inside our team, we are always like one step further. So when I'm looking for the release notes, like on the GitHub, I'm always like, why preview 7? We just finished like RC1, but there is still a little bit of the process before it gets into hands of you as a developers, so you can play with it. It's not like we branch and 2 hours later we have debates and everything. But without any further ado, let's introduce our guest. I will bring him on stage. So we will be talking about jOOQ, and we have the one and only Lukas for telling us what jOOQ is, what it can do, and what we can steal from it and put it into EF, I guess, or something like that, right?
Oh, this is what this is, right?
Yeah, I was not prepared for this.
It's basically
Hi,
live
Jiri. Hi, Shay.
research session. Okay, can you introduce yourself and tell us a little bit about yourself and maybe jOOQ?
Yeah, so I'm Lukas. I made jOOQ, what was it, maybe 16 years ago. I've been doing jOOQ as a professional company in the meantime. So for maybe 12 years, I'm selling commercial licenses around jOOQ. It's still an open source product as well, but it's also dual licensed. jOOQ is an internal domain specific language, which models the SQL language in Java. So you can write SQL statements in a type-safe way. So the Java compiler will type check your SQL queries for you. And we're going to get into the details of that, I'm guessing.
I'm personally excited because we are usually kind of closed off in our .NET world in this show, and this is we don't usually do this, like bring somebody from the Java world or from a completely different world. And I'm personally very much looking forward to this exchange and learning more about what it looks like in a completely parallel universe, right? So
yeah, it's the same in the other way around.
Super cool.
Okay, well, I would start with a question that it's always interesting for me, and it's not technical. How did it become that you started jOOQ? Was it like scratching your itch, or were you ever interested in writing object relational mapper, or what?
So there are two things that happened to make jOOQ happen. The first thing is every company had their own jOOQ, So when you have dynamic SQL, you have to have some sort of API to abstract over the string concatenation, which you don't want to let the junior developers do themselves. Otherwise, they will shoot themselves in the foot in terms of syntax correctness and SQL injection. And everyone had their own APIs, right? So they could do maybe just where clauses, concatenate and or expressions, and they're always very simple. So every company had this. And the second thing was when I studied at EPFL in Lausanne, there was a professor who was teaching Java. At the time, Java wasn't really a very old language yet. So that was in 2003, I think, when he told me, or maybe even before 2002. And he said, in principle, every language could be modeled as an internal domain-specific language if you just had an interface that returns another interface, that returns another interface. And you can model pretty much any language as an internal domain-specific language. And he just said this like this. He didn't even have it in mind. But this kind of stuck to my head and lived in my head rent-free for a decade or so until I realized, hey, actually, that's a pretty neat approach to modeling the SQL language in Java because, all these builders and everything, they're nice, but they're just normal APIs. And if you make them fluent or not is not really very important. But for a SQL query builder, that most companies just used some sort of API technique where you can add stuff to a query object and etc. It doesn't look like SQL, it just does the job. And I thought, why not combine those two things? So first off, you have the functionality of making dynamic SQL, and secondly, you make it look like actual SQL. So people would love to use it, right? Otherwise, these APIs are usually pretty hard to use. But if it looks like SQL, you think in terms of a SQL statement, and you think of select, from, where, group by, etc. You just write it down like you would in a text editor or in your dbeaver or whatever SQL Server Management Studio. But it's Java code, then I think you're going to be much more productive, and that's how it started. A long time ago.
I mean, we've all been there. Personally, I have been in at least two situations in my life, like two companies or professional situations, where there was a homegrown, SQL thing, basically a thing to string together, to piece together SQL and to generate SQL. And I think we've all been there, right? But that does lead me to continue on Yishi's question. Obviously, the Java world had ORMs before you showed up, as we all know. And I'm kind of interested in how jOOQ compares to the original landscape. So I worked with Java back in the days. I mean, I don't even know what it looks like today, but I worked with JPA, the Java Persistency API. I think I worked with Hibernate a little bit back in the day. And of course, we have Hibernate in our .NET world, which is a sort of a clone of Hibernate. But can you tell us a little bit about this whole stuff?
Yeah, so when I started the first prototypes of jOOQ, Hibernate was not very mature yet. I think it was in version 2 or 3 or something like that. It was not the industry standard yet. So some company used it, but a lot of company also used TopLink, which was a competitor product that has been rebranded as ClipsLink now, which is the reference implementation of JPA, even if it's much less used than Hibernate today. But there were different competing APIs, and there was even a third ORM that didn't follow JPA. I forgot the name. It's quite dead now. But it started from the object database hype back in the early 2000s. So there was a lot of things in the Java ecosystem. I think much more than in .NET, because Java has always very much embraced open source. Like for instance, Sun Microsystems. They made the bare minimum at the time to have libraries in Java, but all the detailed stuff, like date time arithmetic and all these kind of things, Sun wanted the community to contribute as in terms of open source. So it's kind of different from the Microsoft ecosystem, where I think Microsoft offers much more out of the box. So we had a lot of competing APIs. I see in the comments, Simon Martinelli. Hi, I know him. He says it was called JDO, the other ORM. That's exactly what it was. JDO, that was a big one in 2000, but I don't know why it died in the end. I guess some companies are still using it, but it's not really mainstream anymore. So this started like that, and jOOQ was not known. Obviously, I just kept it in private. I prototyped it a lot of times before I published it the first time in 2009. So I guess jOOQ was a little late to have been an industry standard in the beginning. It was also not as impressive at the time before Java had generics. It didn't work as well as it does today. So when I started jOOQ, that was Java 1.4 before generics, 1.5, and it was a terrible time. I guess you remember the same thing in .NET. You also introduced generics at some point, but I think you were able to have a clean cut at the time, because .NET wasn't as popular yet as Java was. So for us, it was a huge change.
Like the last time I looked at Java, so .NET 1 did not have any generics, and .NET 2 introduced generics. But what I do know, like one of the things that is always said is in Java, .NET generics have type erasure, right? Like at runtime, you don't actually have, or did this change since the last time I looked at it?
No, we don't want that to change in Java. So everyone relies on erasure now. I don't think anyone would be able to upgrade their libraries if this would be a huge breaking change for everyone. So I guess that's going to stay.
So just for our crowd, for people who are not in the know, again, this has nothing to do with persistency. We'll get back to ORMs in a second, but in .NET you have generics, right? And you can, if you in runtime code, like at runtime, you can look at the type of something, like using reflection, and you have all the information. So the actual generics information is fully represented in there at runtime, and the JIT, the .NET JIT knows about it, and the reflection API can access it. But in Java, that's not the case. It's a purely compiler kind of thing. And the moment the compiler kind of, and Lukas, you will correct me because I'm no Java person whatsoever, but as the moment your code goes through the compiler and gets compiled to bytecode, basically generics are out of the window and do not exist anymore. So it's purely let's call it a language kind of thing.
There are some exceptions in some special cases where they still have to stick around, but that's a very technical detail. So for most purposes, you're correct.
Okay. Yeah.
So,
anyway,
even if jOOQ wasn't published yet, at the time, all the ORMs, like all the JPA ORMs and JDO, they all focused on one main aspect. It was the ORM, the mapping of objects to relational world. And they didn't have a big focus on querying and the SQL language. So most ORMs try to model the fact that you have some sort of representation of your data in your client, and you want to serialize that, and you want to load that, and you want to optimize the loading and the serialization, like you do with Entity Framework as well. And this focus was justified, obviously, because it's a lot of work to do that manually. You don't want to have, if you have a huge application with tons of entities, you don't want to serialize every little change in a handwritten update statement. It's just too time consuming and error prone, obviously. So ORMs focused on this, and in my opinion, they neglected the querying for a long time, at least in the Java ecosystem. So for instance, now JPA and Hibernate are going to catch up a little bit with more modern SQL features that we're going to discuss afterwards, I guess. And jOOQ from the very beginning had this idea that if you can write something in SQL, you should be able to write it in jOOQ as well. And if it's not there, it's just not there yet. So if you have some SQL feature like common table expressions, which are SQL's way to declare variables in a query, so you can pretty much translate that one-to-one to jOOQ API, or if you have derived tables or union operators or window functions or whatever, you should be able to express the same thing in jOOQ. And I think that was one of the most important differences at the time when jOOQ was created. So obviously, everything is always dynamic, as I said. So jOOQ query is always dynamic, even if you use very advanced SQL features.
Does it make sense to jump and just show our spectators what it actually looks like, the code for a second?
Yeah, so I guess a lot of folks in the audience have never seen jOOQ, so I'll just quickly show on the website. This will be the front page of the website. And when you scroll down, you see some examples. So the idea is really when you have a SQL query, you think about it, like select title from book, you can just pretty much one-to-one translate that to jOOQ API. And there are a lot of similar APIs in all programming languages by now that do select from where, but in jOOQ, you can really just pretty much every SQL clause will have a representation in jOOQ as well. So this is a little bit more complex made-up query, but in the manual we'll see also other examples with plenty of other clauses, not just for querying, but also for writing SQL. So if you have insert, update, delete, merge, it's also supported. If you have create table, alter table, you will find all sorts of statements.
This is, this is awesome. And again, for our audience, this is what I think was meant by the idea of a DSL, like a domain-specific language. We're basically seeing a representation of SQL within Java, right? Within a completely enclosing language, let's say. Java is the enclosing language, and we have a sort of a DSL island within that Java language, which represents another language, which is SQL, right? Like that's basically what we're thinking.
And since it's a DSL, and as I said before, how it's designed, so when you have this object here, that's the entry point. This in the manual, it's just called create for whatever reason, and then you call select on it, and that will return a type that has all these methods here available. So you can write from, but once you've written from, you can't write select anymore. So it's just like the SQL language. You have some sort of syntax that you have to follow. So when you write join on this from object, you have to write on or using, because that's the mandatory clause in SQL as well. So this interface that is returned from this join method here will not allow you to type anything other than on or using. And it goes further. So you see these objects here. These are this is your schema, and you're going to be using a code generator for the schema. And every table and every column has a representation in your Java code. And this ID column here will have the integer type associated with it, or big integer type, whatever, in Java long. And you can't compare it with something that's not of the same type. So there's generics again. That's why I said before generics, it wasn't as impressive. But now with generics, you can compare to integer columns or to string columns, but never to incompatible columns. This is really powerful. At the same time, also the names of the columns are always available to you because it's compile time safe with code generation.
Right. So again, just to make sure everybody is following with us, the alternative to this is, of course, you can write your own SQL string here, right? Like there's nothing stopping you from writing a SQL string and putting inside select this from that, but then it's just a string. Nothing makes sure that it's okay. If there's any sort of error in there, like you have a typo in your column name, you will know this only at runtime. At some point when that query happens to get executed, you get an error from the database, right? Whereas here, you're getting static typing, you're getting type checking, like what Lukas was just saying about you can't pass a string into a thing that needs an int. Like you basically get all the advantages of statically typed languages, right? Of Java or .NET and whatever, it doesn't matter. Right here while you're writing SQL, right? Like that's the really nice thing here, which I personally like. I absolutely love this kind of thing. And every single time in my career where I had to write SQL by hand as strings, I would have loved to be able to do this instead. And then you go and you refactor something. Let's say you want to rename some column in the database, then this actually works, right? If you rename the column in your database and then you regenerate, I'm assuming, the code with jOOQ, then at the very least you get a compile time error, which you can now go and that's great. That's amazing to get a compile time error. Like you know that if your program compiles, that means that it's going to work, which is an amazing thing compared to all these magical strings containing SQL, which God knows what happens when they actually run, right?
Absolutely. So this is one of the main reasons why people really appreciate jOOQ. So they have the safety and they know exactly what they're doing, and they're not going to forget something. So even more than just getting compile time error, you can also use your IDE to check where is this author ID column used. So your IDE knows every single reference to this author ID column and can tell you all the queries that use this column or the book table or whatever. So this goes much further than just compile time safety. It's like ordinary Java code. And if you have a comment on your column or on your table in the database, or in SQL Server, it's called a description. So you get Java docs generated from that. So your database documentation will also be embedded into Java code, so you can directly look it up in your Java code instead of having to go to the database to read the documentation. So it kind of feels like the database is really part of the Java application, even if it's something external.
Yeah, we have if users know this, we call this sort of feature scaffolding or reverse engineering, like reverse engineer the database into a code model. EF Core is primarily like let's say you usually start with a code first sort of approach. So you write classes, right, in .NET, and those classes represent tables in the database, let's say, and then you can use migrations to create a database from that code model. But you can also do the reverse. That's why we call it the reverse engineering, where you point EF at an existing database and you get just normal classes. But this is where things are a bit different. In EF, they're just what we call POCOs, like POJOs in Java. They are really simply just normal classes which get mapped to the database, and you can still use them to query, and we'll get to that afterwards, right? But yeah, this idea that you're basically pointing your ORM to the database and you're generating something that now you are programming against, and that thing represents your schema with everything, all the richness and the type safety and everything. That's an amazing thing. That's very important.
Yeah, it's a philosophical question if you want to go the one way around or the other. I think in general, there's not really strictly a better way, but from my background where I worked before, I was a very Oracle heavy person 10 years ago when I still, or or 12. No, it's I've been doing this for so long. It's 15 years ago. And I've been tuning Oracle SQL queries, real big monsters. And I always thought that there's this one architecture where the database is always first because it will always
Right.
survive all the client applications. You might even have multiple client applications. So this was the typical architecture from the 90s. And I still think it has a lot of merits, even if it's not as popular anymore today. But if you have a database that is really very well designed, it follows an ERD, it was designed with an ERD, then everything is normalized. It will survive all your applications. So even Java, maybe tomorrow you'll query it with JavaScript, and God forbid, maybe even Python. Not just kidding. But you could have so many clients, and the clients shouldn't be opinionated about the database. It's the other way around, right? So the database is the contract and the source of truth and your design. And when you query it with whatever client language, you have to adhere to the design of the database. So this is the philosophy behind jOOQ. So it's not strictly the best philosophy or the only one, but it's the one behind jOOQ. So it's still possible with jOOQ as well to go the other way around. You can still generate your database schema from whatever Java object, and then reverse engineer it again to get jOOQ tables.
Yeah.
Or what I don't like to see often, but some people even write the jOOQ objects by hand. So it's possible to do what you've seen here with the book and the author ID. You can do that manually as well, of course. But the optimal way is really to first design a database and then think of
on this. I mean, as you said, this is a place where there's traditionally been a lot of philosophical debates, and a lot of people like really hate one of the options and really love the other, and these kinds of things. And indeed, I mean, I completely basically agree with what you said. This idea that you have one big database that's like organizations where the database is the source of truth, and there's DBAs, which are also the gatekeepers and the ones who decide what the schema looks like and so on. And then the developers, in a way, are sort of just kind of latching onto that, right? They're basically just building front ends to that sort of the information schema. That's let's call it a more traditional way for an organization to function, which by no means it's wrong or bad or outdated, right? It is a little bit, I think that we are, in general, my experiences, we're seeing as you go more modern, that maybe you see a bit more alternative. So I do have the sense that you have more examples of the developer being sort of in charge and starting to code something, basically, and developers are basically they're coders first. So we see this a lot in EF Core. You start out with coding up some .NET classes, right? Like you're in .NET, that's your language, that's what you know. Maybe your SQL is actually not that strong, and we'll talk about this more later. Maybe you're not a database first kind of guy. You're basically a .NET programmer or whatever. So you code up your classes, you treat them just like you would normal classes, and then you use an ORM to map them to the database and to map those queries to the database, right? Which is a different flow. And that's a flow where the code is going to be the source of truth, right? Rather than starting from a database, which a DBA kind of designs and thinks about the schema and so on. You start with a code model, and then it gets mapped to the database. Exactly how is maybe a little bit less important in the very first stages, definitely in some sort of rapid prototyping kind of thing. You start like this, and anyway, these are competing ways to think about the problem.
I mean, I have my opinions about this approach. In the end, I mean, I learned how to properly design a database and how to properly normalize it and why you do this, right? So once you do this, you start thinking about your business, and you start thinking about your business logic, and you start realizing, oh, I haven't thought about this and that because this is not a one-to-many relationship. It's a many-to-many relationship.
Right.
You start realizing these things as you design a database. And if you just prototype random stuff, if you start shipping prototype stuff like this, migrations will be very, very painful. And you should, in my opinion, you should perhaps prototype a little bit less and think about problems a little bit more, in many cases, at least. I mean, I've never programmed a simple website. I guess there it's totally viable not to think about data representation. But if you're doing something for a business and you have maybe 200 entities, and that's not a big database, in my opinion, but maybe you have 200 entities because you have 200 things that you have to track. And if you don't do that properly, you're gonna have so many headaches later on. And
absolutely,
I think it's not about SQL. I mean, the SQL query language is a bit weird and arcane and old. I guess today, or even at the time, I mean, Stonebreaker was always not a fan of SQL, and he would have preferred a more functional programming language already at the time. But the relational concepts, they're not really foreign to all of our programming languages. They're not that different. And I've learned from a lot of jOOQ users that they were living in this cloud or bubble or whatever, where everything had to be object-oriented in Java and code first. And they were taught that SQL is something they shouldn't learn, and it's old and it sucks. And then started realizing, hey, actually, it's pretty cool, you know? The SQL query is, in the end, it's kind of algebraic. You can kind of reason about it. You can transform it in a side effect free way, because it's a functional programming language, even if you have to squint a little from modern perspectives, and it lacks a lot of features. But still, then the fact that it's so simple and declarative makes it very elegant. And they started learning SQL from the jOOQ manual, for instance, or from just auto-completing jOOQ queries, and started realizing, oh, there's this operator. I'd never heard about it. It's very cool. It can do cool things. I actually need just that. And once they started learning SQL very well, they started moving more logic into their queries, because actually, in a lot of times, it's much simpler. You know, when it's data related, at least, obviously, you're not going to do some UI stuff in SQL. But if it's data related, a lot of times the SQL query could be very compact for maybe thousands of lines of Java code. That used to be a talk I gave at conferences, you know, 50 lines of SQL or 2,000 lines of Java. And I've seen my share of...
So I'm with you there. I personally love SQL. Of course, we're ORM writers. We are very intimate with SQL as well, and so on. I absolutely love it. I think it's very elegant, especially for something that old, and it's still amazing how much it solves the world, like a lot of the world's problems in a very effective way. So I'm absolutely with you. But here is where I keep pushing into a more controversial area on purpose. But I mean, I'm not challenging or anything. We do have a very clear idea that in many cases, what users want to do is they want to be able to code, and the SQL as a language is a detail that they don't necessarily want to understand. And this kind of brings us to also one of the key differences between something like EF Core and something like jOOQ, which I wanted to say, but maybe we should do a small pause for comments, by the way. Jiri, I don't know what it looks like there in the comments. What do you think?
Yeah, I think we have a few comments in here. This is funny, and I was hoping that somebody will say it. Are there any plans to release Nuke, .NET version of jOOQ?
I mean, the name is already amazingly wonderful.
Exactly. Yeah, I think somebody should definitely do it. And
I wanna go back to this, by the way, after we've discussed the next subject of Link and jOOQ. Yeah.
And although it was answered in the comment section, in case somebody's watching the recording, there was a question. Maybe this was said already, but those constants, for example, author.first_name, are generated for you. If you want to answer that.
Yeah, I mean, the capital letter objects here in the screenshot are all generated objects, so the database is reverse engineered. Whenever you want, you can include this in your build, or you can do it manually.
Yep.
Awesome. Yeah, I think that's it for the questions, and we can just continue forward.
So on this, I want to push to one point, because we were talking about SQL and whether, what users feel about SQL, and users suddenly learning SQL through jOOQ and things like this, which I find fascinating. Everybody take a look at the screen right now where we see jOOQ, where there's a DSL that expresses SQL inside Java. And then Jiri, if you can switch to my screen, which is just an introductory page in the EF Core documentation, just to show like what things look like in the other world. Maybe
if you can zoom a little bit, because it's painfully small.
Let me do that indeed. How does that look? Is that better? More?
A little bit more, probably. Yeah.
Like this.
Yeah.
Let's do YOLO. I'll go even more. This is like a 200% zoom. So the main point that I'm trying to make here, and like most people on this watching this show are actually familiar with EF, so I don't have to spend too much time on it. But EF's querying solution relies on a language feature called LINQ, Language Integrated Query. And .NET is quite unique in having something like link, like technically link, like link is many things, by the way, as well. I'll talk a little bit about this, but everybody knows link who knows .NET. Link is just at its base, it's a set of operators. For example, the filter operator is called where. You've got other ones called like take and skip and order by and select for projections and things like this, right? Now, the magical thing is that this same set of operators, which are just functions, right? In .NET, they are functional operators, so they accept functions. This arrow here, of course, means that we're giving a function which will get applied to all of the blocks here, right? So that's link in general. But the amazing thing about .NET is, up to now, what I've told you exists in other languages as well, and you have objects in memory, and then you can filter using this sort of functional paradigm, right? But what .NET did, which is really, really quite astounding, is they have what can be called a certain quotation device, meaning that you can write an ORM like this, like EF core, where the root of your your link expression is something that comes from the ORM and represents a table in the database, this blogs thing, right? And then the where thing, although it looks like the normal link where, it is not. The normal link where is what we call an enumerable operator. It just operates in memory and runs your functions like as expected. What you see here is something very different. We are actually constructing here an expression tree behind the scenes, so a tree representation of your query, and then EF core is responsible for taking that tree and translating it to SQL and sending that to the database, executing and doing all the rest. So we have the main thing here is, if you compare it to the jOOQ approach, and this is not better or worse, that I want to, like, it has pros and cons, which I very much want to discuss, but I'm not trying to say that this is better in any way. But compared to the jOOQ experience, you are not talking SQL here. What you are talking is C# or .NET. That's very, very important. So the developer doesn't know anything about SQL. They don't know that they need to have a select or a join or anything of the sort. All they do is they express themselves using the normal .NET mechanism of link. And EF is responsible for taking that thing, that input, and translating it to SQL. So this is a much more high level, much more abstract approach compared to any other ORM that you'll see in any other language, because we have link. You're expressing yourself with very abstract querying approaches, operators, and EF is responsible for the heavy lifting. I'll give you just one example. Like, this looks simple enough to translate, right, to SQL. But imagine that instead of doing b.url, we would say something like b.blogdetails.url. So there would be an additional dot here, and there's like an additional object that's referenced by the blogs, or even something like b.posts.orderby.first.url, right? We can continue chaining operators here. This looks like link, but in fact, what will happen behind the scenes is that EF will generate a join behind, like in the SQL that it generates, right? So you don't have to think about stuff like join at all. You're not aware even that there's actually joins happening, not in this particular query, but again, if we added a dot in here, EF would generate a join into it, join from it, right? So we have two very different ideas of how one expresses a query in the jOOQ world, and you know how you see it in most other languages. The user writes SQL. They write it in a strongly typed, very cool way with DSL, whereas in .NET EF Core, you don't write SQL. You write a link query, and EF translates that into SQL for you. That was just an introductory thing, and now I'm very much interested in discussing, how these two approaches kind of pair against each other. So first, go ahead, Lukas. I'm sure you have something to say.
Yeah, sure. Just a quick injection. Regarding those paths that you mentioned, the blog.details.everything. So jOOQ has this feature as well. It translates to a join. It's called an implicit join in jOOQ. Hibernate has
interesting.
This as well. The Hibernate query language had this for ages. And one of these days, I'm gonna look into how I'm getting into the ISO IEC standard committee to get this into the SQL standard, because I really think this should be a part of the SQL standard. This notation.
Oh, good luck there.
Yeah, I know. I'm just saying this out loud, so I get pressure. I'm probably not going to do it, but it's something that is worthy of the standard, because the semantics is very clear, both when you read it and also in terms of how you would design this feature in the language. So you would just have in SQL, you would just need one more thing. In DDL, you would have to define how the label is on this path, and then it's very clear how to join to one and to many relationships, and you can go much further than that.
Sure.
I think the main difference.
Just one question, if I may interject. So? If I understand what you're saying, this would be an implicit choice. So behind the scenes, the database would be doing the exact same thing, right? You have two tables, and then it would have to be correlating the correct rows and doing a join. Like we're still talking about a normal relational join, just implicit in the query syntax.
Yeah.
Right?
So here you have this book table in the from clause, and the fact that you added book.author somewhere in the query means that this book will be replaced by book.
Right.
Author.
So then that's actually quite similar to what EF Core indeed does, and that's super cool to see. So that's indeed very, very relevant. Yeah. Sorry, but I interrupted you.
It's also in a PHP ORM once. I forgot the name, but it's not a very it's a how to put it. It's getting more and more popular, I think.
Interesting. I wasn't aware that this was a thing in other. See, so the thing with Link is since you're since you're expressing yourself with .NET, and it's a very natural thing, right? You're starting from a place where you're just using .NET, so obviously you're just dotting into objects and everything is there. Just like, by the way, in the jOOQ case, if you want to do an equality, you have to use some jOOQ specific mechanism to express equality, obviously, and that's completely fine. In the .NET Link world, because it's a quotation and everything, you're using the same .NET equality operator that you use anywhere else, and we get it as an expression tree and then translate it into that's fine. That's all fine, of course.
So I've always wondered, since now I'm talking to you folks, I've always wondered in Link, obviously you can express C# code or whatever language codes that can't be translated to SQL because there's just no representation. And then how do users run into this? They will just get compilation errors?
That's a great question.
And what the problem is?
That's a great question.
I would never want to have this in jOOQ. It's just my opinion, but mixing the two languages at some point gets really dangerous, especially for beginner programmers.
Yeah, so I would say, so first of all, just to answer your question directly, you do get a runtime error, right? You will get, Link users, like EF users are used to, if you do the wrong thing in a Link query, you will get a runtime exception saying this cannot be translated into the database.
Oh, runtime, not compile time.
Runtime. Now, there is, like in a very theoretical world, this is very hard to do. .NET also has something called analyzers, which work at the compiler level. So we could, in theory, do a plugin into the compiler, which analyzes Link queries and then does compile time warnings or errors if you write a Link query which we can identify to be unsupported. It's very hard. We haven't done this. Users would love for us to do it, but there's a lot of reasons why it's very hard to do this. For one thing, I'll give just to give an idea, EF, because it's such an abstract thing, Link, EF actually supports non-SQL databases as well. You can use EF to also work against Mongo and Cosmos, and in theory, anything that can be queried, you could use Link over that, right? I even wrote, like earlier this year, I wrote a vector database abstraction where you can query data, you can use access databases like, this is a completely different universe here, but Quadrant, Milvus, Chroma, these databases which are dedicated vector databases for similarity search in the, for AI, they have most of them have a mini filtering language, and we abstracted over that via Link. Most of the things you can express there will not work. You have to only do the things that do work, right? Like, because they're very, very constrained compared to SQL. But yeah, that is one of the major disadvantages, because this is an abstraction. In some databases, it will, like, your query will work. Even in Postgres, it will work, but in another database, it will not work. So yeah, good point.
It's the same thing with jOOQ as well. I mean, jOOQ supports pretty much everything that you will find in some SQL database out there. For instance, Oracle is one of the most sophisticated ones, and jOOQ supports a lot of Oracle features, which will then not work on SQLite, for example, right? So,
of course not. Of course.
jOOQ's API has annotations to document this, so you can have a compile time checker that will prevent you from using a jOOQ API that's not going to work on your database. But
so when you say compile time, when do you mean, you don't mean like Java compilation, right? You mean a compile time?
Java compilation.
So you can hook into
checker. You can do compile time validation with a checker dependency that you can add to your compiler, And
I
the
see.
dialect checker will then just throw errors when you, for instance, you allow H2, the H2 database, and if you're using something that H2 doesn't support, will you get compilation errors.
Very interesting. Okay, yeah, that's very cool.
So it's the same thing. It's less abstract than LINQ because it's still SQL, and it will not map very well to non-relational databases. But in theory, it
Of
would
course.
be possible. I don't have plans to support these. Some people ask me to support MongoDB or what was the other one called? A few other NoSQL databases, but it would cover, maybe the jOOQ API would be implemented to a 10% or 5% stage, and it's just not something I would want to publish in terms of quality, because
Of course.
it
Yeah.
technically it wouldn't make sense, even if those people would like to have it. But the idea that you had, that your API, the LINQ API, is much more abstract. I think I've seen this a couple of times in other languages. For instance, in Scala, they had Slick, and it's now been, I forgot the new name. Slick was by Lightbend, and they have the same thing. So kind of like LINQ, it mimics the normal collection API that the Scala uses and the normal terms. So they're not going to call it select, but a map, and they're not going to call it join, but flat map, and they're going to map and flat map to SQL operators. So the model there is that the mental model is also, you think in terms of Scala, you think in terms of Scala collections, and your collection happens to be a SQL table, but you don't really think about it this way.
Exactly.
You don't think in terms of joins.
Exactly.
And even Kotlin, they started with Exposed. They started following this approach at first. I'm not sure if they're still seeing it through, but
so I actually think, like, I'm not the only one. I think .NET, .NET modeled its LINQ operators. The naming there is SQL naming. So it's really called, like you just said, it's called select and where and join, which are SQL names, rather than the more functional standard names of map and filter and all this. And I would have been happier with the functional names, by the way, but it shows you to what extent the whole idea of LINQ was kind of sort of half started as a way of modeling SQL inside a language, right? Like that's really the history of LINQ is very tied together to the idea of doing ORM.
At the time, I saw a talk where Eric Meyer and Simon Peyton-Jones were discussing how to bring imperative programming and functional programming together. And Eric Meyer's opinion was that maybe if we trick ASP developers, Visual Basic and everything, to think in terms of, oh, this looks like SQL, then they're going to start using the functional stuff,
right?
At least. And I thought it was quite cunning to
something like this happened in C#. So C# is obviously an imperative language originally. It's just like Java. It's very, very classical object-oriented imperative thing. But if you look at the changes in C# in recent years, a lot of it is basically introducing functional concepts into C#. Not necessarily around the LINQ thing. That's an older thing. But even if you just look at actual recent C# things like switch expressions, like a lot more things are kind of functional in general, right? So that gap is sort of a little bit closing, but that's beside the point for the whole ORM thing. But I will say this, like where we have a rough time, like to give you an example. So the LINQ where is pretty good. It translates directly to SQL where, and LINQ order by translates directly into SQL order by. But LINQ group by is something completely different from SQL order by, right? Like obviously, so SQL order by requires you to afterwards do some sort of aggregate functions to reduce the results back into a relational table structure, right? This is how SQL works. It only supports tabular, like basically sets of rows, right? So you can't have a group in the sense of that .NET LINQ has a grouping where you say group by some key, and then you have a list of lists. That's basically what group by does.
Actually, can. You're wrong. Actually, SQL has multi-set and arrays, and this is what jOOQ offers as well. So I'm glad you mentioned it. This is jOOQ's most awesome feature, I think. Multi-set aggregation, when you do this, so here you have this group by statement. This means you want to group by actor, and then for each actor you want to collect their books as a nested collection, and jOOQ can actually do this.
What is the format of the nested collection, like when you read it back from the database? It's JSON, right?
Be a list of records. So behind the scenes, some dialects support it natively. Most dialects use JSON.
Exactly. Yeah, exactly.
It's hidden for you.
No. So you no, absolutely, and you're right. I'm actually a Postgres person, by the way.
Yes.
I'm 100% a Postgres person, and I developed the Postgres driver for .NET, and the EF provider for Postgres I'm the only one working on it, so I'm very, very Postgres oriented. And Postgres has the idea of arrays, right? Which kind of no other database has, or most other databases don't have. A lot have JSON and are kind of like, if you look at SQL Server is using the concept of JSON to sort of to provide a sort of an array concept, and it makes sense in some ways, right? But SQL as anyway, traditional SQL anyway doesn't have that kind of thing, right? And one of the very interesting things that we've also been doing very much in recent releases of EF is introduce more and more JSON things. So I'm just going to say, like, if you look at a link query, and once you go into something there with a dot, that thing might actually be mapped to a JSON collection.
All right.
And then you don't know this, you're just writing link, but behind the scenes, we will actually generate not a join, but rather the correct JSON SQL to actually go into that JSON document and get that property out so that you can compare against it. That, again, is something you don't see in the query at all, because that's not your business. You're just writing a very abstract query. But it might be mapped in very different ways, here to JSON, here to a traditional relational table, and so on and so forth. So array ag is absolutely very important and interesting, and I'm very familiar with it. And it's great to see that you support it. I'm very moved.
Yeah, I was just going to say this also because it's really a pity, because it's part of the SQL standard. All of this stuff, ORDMS extensions were added in the SQL standard. Oracle was one of the big drivers here, although they implemented it a little bit differently from the standard. Postgres implements the standard quite nicely, and I really wish more databases did this. You can use those arrays also in store procedures and have a lot of more rich language inside of the database. And I mean, JSON is better than nothing, of course, but the actual ORDBMS features that were a big hype as well in the early 2000s would merit some more attention, I guess.
I mean, as ORM writers, specifically, SQL as a standard is a bit of a disappointment, right? Like, if you actually look at the features across databases, like,
I mean the implementations.
Yeah. I'm not the language as a language, but I'm just saying, every time you wanna, you get excited about some feature, you then have to look at how it's implemented, or whether it's implemented in the different implementations. And in many cases, it's like, your job and my job. I think, like, we're the best placed people to know this, right? Every time you have to actually expose these things to users, you see to what extent this is supported, this is not supported, this is supported but has a different syntax, this thing is like this, like that. Like, it's a mess.
Story of my life. It's crazy.
Yeah, it's very unfortunate.
Like, JOOQ documentation, you can look at any website here. You see all the differences. Even JSON ag or JSON array ag or XML ag. The different syntaxes for the very same thing.
It's horrible. It's horrible. That is one of the reasons, like, unfortunately, right? But that is one of the reasons why I think link makes a lot of sense for a lot of people, because people don't have the capacity for actually going into these differences in general, right? They're looking for some simplification or abstraction over these very difficult stories in many cases, and we provide it to them. You do as well, like in the same way.
I mean, it's obviously a big advantage if the application has multiple databases that they have to support. Like, product vendors will support Oracle and MySQL and SQL Server, etc.
Yeah.
A lot of systems, they are tied and strictly tied to one database management system. So in those cases, I guess it's not too much to ask from a developer to learn the 5 language features that they will use every day in that particular dialect. So I think it's a two-sided sword, I guess. For some people, it's really cool to abstract over this, and for others, it's actually an impediment. They would really like to have the actual SQL. So I think this is also one of the reasons why many people appreciate jOOQ, is because jOOQ abstracts only where it's strictly needed. Like in this case, because it's not available in most databases, and it's such a cool feature that I'm still implemented it. But a lot of SQL features are one-to-one mapped between the jOOQ API and the SQL language that the specific dialect, and it's exactly what they want. They want exactly, in Postgres, for instance, they want to write the specific insert on conflict statement, and they don't want to have some abstraction over that. They want to write exactly this. They know they want to have a conflict on this foreign key, on this unique key, and on these columns. And it's kind of the question is always, how much do you really want to abstract, and how much do you want to give the user the power to express exactly what they want?
Absolutely. And I'm going to argue against myself here a little bit, right? But the EF story goes like this.
Merits.
What's that?
Both approaches have their merits, obviously.
And their disadvantages, right? Yishi and I were just discussing this before this call, right? The EF story is something like this. Let's even just talk about queries, not insert on conflict and all that stuff. But you do a query, as long as like you're doing the simple stuff or stuff that we cover in our link support, then everything is beautiful, right? You're just using beautiful .NET code. It's strongly typed. It's easy to understand. You don't need to know anything. But then at some point, you're going to need or want to do something that goes beyond it. And suddenly you get an exception that doesn't translate, or there is no way to express that in link and so on. And then you hit a cliff. Yishi was saying this very well before this meeting. And then at that point, you really have only one option in the EF world. You have to drop down to string SQL. And then you're in a worse situation than you are in jOOQ, right? Now you're really back to the really, really shitty story of writing your SQL with strings. You can kind of access EF to get at least the column names, like to string them together so that if you rename the column names, then that's not going to break you. So if you really want to, you can do this. Few people do this, but in most cases, you basically hit this cliff and then you're back to the most primitive and awful way of doing things. On the other hand, the question is basically how much of your main user base actually falls into this very sort of advanced scenario, and how much is covered by EF's link support. If it's very high, if 95% of queries and everything are kind of covered by our link story, then maybe it's a good story. If every single user out there has to kind of break out and say, oh, that doesn't work for me, now I'm going to have to do SQL, then that's not such a good story, obviously, right?
Yeah, I mean, it's great to cover as much as possible, but I've always recommended to every user to use more views and more stored functions. I mean, those language features are available to them, and if you have a really, really complex SQL query and you want to have exactly the number of combinations of features and it's static, it's never dynamic, why not just write a view? And jOOQ will reverse engineer your view with its columns, etc., and you can embed it in a jOOQ query.
You're right.
I think
it might even be more efficient with a materialized view. It might even be more efficient with a materialized view or something like that. You might even get performance out of it. Yeah. No, you're right. You're absolutely right. Like we constantly have this sort of tension. So we've taken on being a link provider like EF. By the way, that makes our job, I think like most of the complexity in my job comes from the fact that we're a link provider. Like this extra layer of translating from this expression tree abstraction into SQL is extremely complicated, really, really, really extremely complicated. And that's not necessarily great, right? Like we're doing a lot of work in doing this, whereas somebody like you can concentrate on the actual base jOOQ thing and that's it. And you don't have to think about these very abstract compiler-like transformations that we have to think of, right? We're basically writing a compiler, right? So it's a huge effort that we take on because we give a more high-level thing. And there's even more disadvantages, like you said, where people can express something but then get a runtime exception and so on. And there's these cliffs, and then you have to go into SQL. On the other hand, like our experience, like just to say something positive as well, because there's a lot of positive there still. We're seeing like people are absolutely thrilled with the idea that they can not think about SQL at all and just express themselves in .NET for the 95% case. That's kind of like the promise of Link, right?
Yeah, I get it. Yeah.
And they love it. Like absolutely, people love it. And when we tell them it's okay, just write that one, this one tricky query that you have. Yeah, drop down to SQL. They're like, no, I really, really don't want to deal with the SQL. This is so nice and pure and everything. So that's kind of like the value that you're bringing to your users. But it's this sort of thing where you're telling your users, like you're being really nice to your users. You're telling them, I'll take care of everything for you, right? Which is always like a good and a bad thing. And they have no idea what's going on underneath. And right? Like that's kind of like the pros and cons, the value proposition.
As I said earlier, I mean, jOOQ compared to ORMs in the Java ecosystem, the most pragmatic people will use both because jOOQ does one thing good and the ORMs do another thing well. And if you combine both of them, then you got the best of both worlds. A lot of shops say, no, we have to do everything like this. We cannot. This is the golden rule, and the architect mandated, and that's how it is.
That's interesting. That's even more. I wasn't aware of this, that you have this specialization. You're kind of like really specializing on the query side, and then there's another category of things that specialize on let's say the more modeling and persistence kind of.
jOOQ has something that resembles active records from Ruby. You have a record type, and it maps one-to-one to a table, and it has dirty checking and optimistic locking, and if it's single table based, then you're happy, and you will not write insert, update, delete on that table. That's very useful. So I guess that's the ORM part of jOOQ, but jOOQ doesn't model object relational mapping. So in terms of mapping the object graph like Hibernate or Eclipse Link. So if you have a collection with nested collections and you modify both at the same time, and then jOOQ won't help you serialize that. It's just a very complex problem that I don't want to spend time on. So
tell us about it.
You have in your application, then people will use Hibernate for that and will be very happy.
So that's interesting there as well. This can be criticized or not, all in hindsight, but EF Core really does it all, or at least tries to do it all. It also includes exactly what you said, the idea that you can take a complex graph, make arbitrary changes in your objects in memory, and then tell EF Core persist the changes in this graph to the database. Figuring out how to do that, like there's a whole piece of code inside EF to figure out the dependencies, to know which table you're going to update first based on which update in memory, and how to do it in a way that won't deadlock. So to do some sort of deterministic ordering, like all this stuff is super hard. And honestly, I really respect people who do this kind of thing, because we also do it, and I know exactly how hard this is. So I actually really think like it makes a lot of sense the way you're saying it, that you should pick a thing and concentrate it and do it really well. Because doing everything well is actually really hard.
Yeah, plus I also think in terms of what I've done before jOOQ, these kind of problems are much more rare than persisting into a few tables, and that's not very complicated. You can still do it manually, and querying is what everyone does all the time. So I wanted to focus on the problem that all the people have. And I think if you're an insurance company and you have everything in a temporal table that you have to with temporal versioning, etc., or over an entity graph, these kind of complex problems are so complex and they're so rare that I couldn't even spend time thinking about them, because I don't have the experience in my previous jobs of what is actually the use case. So this is the kind of thing where I just didn't want to how to put it in German would say burn my fingers, I
think that works in English too.
They're interesting problems. I would love to spend time on it, but it's a lot of effort. So there are no plans in this direction.
As I said, that actually makes perfect sense to me. If you have other people, other products basically taking care of that for you, then why would you duplicate it? That's great. Like use each product for what it does best. 100%.
And one other thing that I've hardly ever seen in any ORM is a proper support for stored procedures, for instance. So a lot of ORMs pretend they don't exist, but a lot of systems still have them or do them right now. And especially when you're using Oracle, you have stored procedures and they're rich data types. So they have object types and table types. They even have an object-oriented implementation of their object types. And with the code generator that I've mentioned before, you get Java stubs for all of this stuff. And that's really wonderful to use when you have these kind of databases. Now that's a very rare situation as well, but one that I really deeply care about personally. So if you really tightly integrate with your database, then you get all of these kind of things from the code generator, which I've hardly ever seen in any other ORM, because I guess it's so time consuming and so only few users actually need this. But I think it's a wonderful world. I wish personally that more people would use store procedures, because
that's interesting.
Their funky language is not very well supported in IDEs, etc. But a lot of data processing would be so much faster if you just pushed it into the database using the languages of the database, and people kind of don't think of it.
it's another thing that seems like it used to be much more popular, and it's tapered off a little bit, like from what I've seen. Like people do it much less today than they did 20 years ago. Indeed. Like we by the way, a few years ago, we did a big push on stored procedures for specifically for the updating side. So you can tell EF, for example, that when something is inserted or updated or deleted, instead of doing an insert, update, or delete, map it to this stored procedure call, which can then encapsulate, various things and so on. So it doesn't go very far. This is like not at all like as, and we also can map stored procedures in functions, like in queries. So you can map a thing so that instead of selecting from a table, you select from a stored procedure with certain parameters. We don't go very far in this, mainly because nobody is asking us to go further. Like we're not seeing any sort, like people are barely using these features with EF, and maybe it's just not the kind of users, and people who want to do stored procedures don't use EF so much. Who knows? Like it's interesting.
I've never thought about your insert replacement by procedure. It sounds like a client-side trigger of some sort. But then why not just write a trigger?
No, so this we just so EF, instead of sending an insert into the database, sends a stored procedure invocation, and it's a server-side stored procedure. Like it's completely a server-side.
Usually people would write a trigger, and then they instead of replacing the call in the client, they would replace it in the server. Yeah,
you could do this. Yeah, this is something that we implemented at some point because it was requested in some specific scenarios, and it's an interesting idea, and I agree. It's a bit odd, but it's a thing that you can do.
Yeah.
Okay, I think we are slowly but surely running out of time.
Yeah, in fact, I'm going to have to drop quite quickly, unfortunately.
Go for it. Lukas, do you have something final to say or show? Or I'll put a link to the screen or something like that.
It feels like we could be here for another 5 hours.
So the link to check out would be jOOQ.org. That's the website name, and start from there. You see learn, you get to the manual, and everything is documented there.
Okay.
I personally wish we had like another couple of hours to continue this. Maybe we should do a follow-up session at some point.
Yeah, maybe someday. When I publish jOOQ, maybe.
Yeah.
Maybe we can implement jOOQ in 3 hours.
Yeah, maybe not.
All right, that was fun.
Yeah, same here.
In next month or in 4 weeks, we will have another session. So definitely stay tuned for the schedule on Twitch and YouTube. And see you next time.
Bye, everybody.